Hello everyone, welcome to the video on Mathematics 10. Today we're going to talk about modeling using triangles. Before we start the lesson, there are some important knowledge that we need to have. You need to be able to solve for the unknown side of a triangle, and you also need to be able to find the unknown angle of a triangle given some sides. After this video, you'll be able to use the trig ratios to solve real-world problems involving the angle of elevation and depression. Let's try the example question. A flagpole casts a 15-meter shadow and the angle of elevation to the top of the pole is 60 degrees. How tall is the flagpole? So whenever you do a modeling, especially using a triangle question, it's always important that we include some kind of a diagram. So let's try to draw the situation here. A flagpole, it casts a 15-meter shadow. So let's say we have a sun over there, and the shadow of the flagpole is going to be 15 meters. And the angle of elevation to the top of the pole is 60 degrees. So if we imagine our eye being on the lower left-hand side, the angle of elevation is 60 degrees. So that angle of elevation means that the view from the horizontal view upwards, that's the angle of elevation. So apparently that is 60 degrees here. And the question is asking for how tall is the flag? So we want to measure this length. After you draw a general diagram, then I suggest that you redraw another diagram that is more concise. So we don't need to have flagpole, we don't need to have other things. Let's draw another triangle that resembles exactly that, but more concrete and only including the necessary information. Like that. Okay? So first we draw an actual situation, and then we draw a more muted triangle. Now we need to solve for x. Well, from the point of view of 60 degrees, I know the adjacent side, 15 meters, and I'm looking for the opposite side. So the ratio that we have to use has to involve the opposite and the adjacent. And the ratio that does that is the tangent ratio. So let's write down the formula for the tangent ratio. And then in this case, the theta is 60 degrees. And the opposite is x. And the adjacent is 15. So if we multiply both sides by 15, that's 15 tangent of 60 degrees equals x. And we use the calculator to find the value of 15 tangent of 60. And I get 25.98, or approximately 26.0. So final answer would be the flagpole. In this case, the x value is the length. So that will be 26.0 meters. Remember, it's a word problem, so you answer in words. Let's do the annotation here. The first thing we do is we draw the situation. We draw the situation based on the given context. And then after that, we draw a diagram. We draw the diagram version of the situation, so we only include more necessary information. And then we set up the equations. And solve the equation. And then we answer the problem. Now let's try the second example question. From the top of a 50-meter lighthouse, a boat is observed at an angle of depression of 25 degrees. How far is the boat from the top of the lighthouse? The similar thing, let's first start by drawing the situation. So we have a lighthouse. I'm gonna draw a very easy lighthouse. Let's imagine that, I don't know, it's a lighthouse. That's 50 meters tall. And apparently from the top of the 50-meter lighthouse, a boat is observed at an angle of depression of 25 degrees. So the angle of depression, just like the angle of elevation, is the angle from the horizontal view, except you're going downwards. So I need that imaginary horizontal line from the top of the lighthouse, and looking downwards, that's 25 degrees. And then at this point, you're going to see a boat. Like that. So be careful with the angle of depression. You're not seeing the angle inside the triangle. You're going to see that awkward angle of 25 degrees from the horizontal view and downwards. Now, it's quite difficult to see how we can construct a triangle in this case. So perhaps instead of using the 25 degrees, we can quickly calculate this angle, right? Because if we assume that the lighthouse is standing up straight and we have a horizontal view like that, that's a right angle. So then the other side of the 25 degrees must be 65 degrees. Now, I think we can construct a diagram of the situations without the boat, without the lighthouse, without the angle of depression. I think we can say that an easier version of this triangle would be something like this. At 50 meters here, and that's 65 degrees. And the question is asking for, how far is the boat from the top of the lighthouse? So I think we're trying to find this diagonal distance. So that's going to be the x value here. So after we draw the situation, we draw a diagram, and then we'll solve that equation. So in this case, we know the angle, and it seems like we know the adjacent side, and we're looking for the hypotenuse. So which trig ratio will include the adjacent side and the hypotenuse side? So I think that's cosine. So let's write down the formula for cosine. And we know that the angle is 65 degrees. And the adjacent is 50, and the hypotenuse is x. And you multiply both sides by x. So it becomes x cosine of 65 degrees. And then we divide both sides by cosine of 65 degrees. So therefore, if I'll write it here, x is equal to 50 over cosine of 65 degrees. So if I put that into the calculator, 50 divided by cosine of 65, and the length is approximately 118.3. So that's the x value that I got, which makes sense. Given this triangle, the hypotenuse is significantly longer than the adjacent side, so that's good. So let's answer the problem. The boat is 118.3 meters away from the top of the lighthouse. Let's annotate the process. Quite similar. We first draw the situation. And after, in this case, because we're doing the problem including the angle of depression, after I draw the situation, I also found the other angle. Okay? So for angle find the other angle to include in a triangle. After that, I draw a diagram. And then I set up the equation, solve the equation, and answer the problem. It's quite similar as the previous problem, so I'll skip that part. So in today's video, we talked about two important vocabulary that we have to know: the angle of elevation and angle of depression. Once again, the angle of elevation is the angle that you see from the horizontal view and upwards. That's angle of elevation. And same thing for depression, except you're going downwards this time. Most often, for the angle of depression, we're going to need to find the other side of the angle. So we know the angle inside the triangle, so then we can solve the triangle to find the answer of the problem. Thank you for watching this video, and I'll see you in the next one.